Some time ago, while browsing YouTube, I came across a video by Sebastian Leek about creating an ecosystem. The idea seemed pretty interesting, so I thought, what if I create such an ecosystem, not in Unity, but in C? The idea itself is quite simple. At the very beginning, you create an organism and give it parameters, such as hunger or reproduction desire. Later, you just throw few of them into an area and done. Seems easy, right? So let's start by creating a basic organism. First, I had to make it look good. I could have made it just a circle, but I felt that would be a little bit too boring. That's why I decided to create procedural animations for our organisms. I was inspired by a video by Argonaut about procedural animations, which made me realize that they are not as hard to do as I always thought. At the beginning, I created an array inside the organism structure to store its segments. A segment is nothing more than a structure that stores position and radius. Based on this, I could easily draw multiple segments for each organism. The next step was to ditch those boring circles and replace them with a cool outline made of connected lines. I think now it looks quite nice. All that was left was updating the position of each segment based on the previous one. This is done by calculating the direction to the previous segment and then assigning the current segment's position as a sum of previous segment's position and that direction multiplied by the segment's radius. With the help of a great explanation of Argonaut, I managed to create a pretty satisfying organism animation, and instead of boring circle, we ended up with this. Now it's high time to create a movement system to the organism. When the organism isn't driven by any needs, the program generates a random target position within the window's edges and makes sure that the distance from organism doesn't exceed 300 pixels. However, when a need appears, for example hunger, the organism searches the food array for the nearest unit, saves its index and sets it as a current target. Thanks to storing the food index, it's easy to remove it later and check whether it still exists. Reproduction works in similar way, but with additional verification step. The chosen organism must also have a high reproduction desire. Without multiple fillings, there are no point in expecting offspring. To make everything work smoothly, I created an organism graph structure that stores both the array of the organisms and their count. Now it's time to make the simulation a little bit more colorful. Now the simulation looks much more lively and interesting. Now it's time to add the predators. Because life of our basic organism can be too easy, I decided to add 2 predators after 100 seconds, giving our basic organism time to reproduce. Predators in my ecosystem are simply basic organisms, but with 3 differences. Firstly, they are bigger. Secondly, they are faster. And thirdly, they feed on other organisms. Additionally, they are purple. And this is how the complete simulation works in action. I started with 16 basic organisms. After 100 seconds, the population reached 50, which was quite promising, and it was time to introduce predators. Although it initially seemed that the prey and predators could coexist, it quickly became clear that the predators were eating their prey much faster than the organisms could reproduce. The predators, despite their initial success, after 300 seconds probably realized that they had made a fatal mistake by wiping out their food source. This led to their own death by starvation. The simulation ended with the complete extinction of all organisms. Well, nobody said survival would be easy.